Hello everyone, my name is Abayomi. You're welcome to the part 3 of building production grade REST API. So in today's lesson, we'll connect to our MySQL database using Prisma. So let's get right into it. So I'll open my terminal and we'll zoom in a bit, clear. Then we will install Prisma Client. So npm install add Prisma Client. So then if you check your package.json, you should find the Prisma client here, somewhere around here. And also let's run npx, that is node executor or node package execute. Then we do Prisma init. So this will create two things. We have the Prisma folder here, then the schema of Prisma here. If you want to learn about Prisma, you can click on this link, but I'll remove all these comments. Then I will change our provider to MySQL. But if you want to use Postgres, you can just leave it the default. And also, if you check your .env, it will create this connection string. We have database URL Postgres, change this guy to MySQL. Then we can change it to my root user and my password. Then we can call this Prisma DB, and let's remove these guys, and we have our development here. So step 2 is to come into schema.prisma. Then we write our models here. So we're writing a user model and a blog model just to keep it simple. Alright, model user. Then the ID will be of integer int. Then we can do at ID. Then this guy will be default. Then auto increment. Then we can have our name as string. Then we can have email as string. Say we have this annotation of unique. That is, we can have two users with the same email. Then we have our password as string. Unique. It's unique. Then profile picture. Call this guy string, and this will be optional. Then we have created art. Then this will be of type, data type of datetime, and the default will be art annotation default. Then we can pass the now, that is the current datetime. Then updated art will also be datetime. Then it's verified, should be a boolean, verified boolean, and the default will be false. This guy is blocked. Default should be false, and we need a row. So to write our row, I'll use an enum. So enum, call this guy row. Then we have 3 rows. We have admin, to be 1. Now let's put our user first. Then admin, and lastly super admin, like so. Oh, okay. We need to remove the comma. Cancel. Then now for a row, we can have row of type row. So this is the field name and this is the type. So we're saying the field name references this row type here. Then the default annotation will be of user, like so. By the way, this guy should be capital letter. Then we can give our table name. We can name our table as at using this double app map. Then we call it users. So this is our user model. It has an ID, which data type is integer, auto increment, name, string, email, and so on and so forth. And it has a a row, by default, you have the user row. So let's create another model called blogs or blog. Then we can also copy the ID here. I'll paste it here. Then every block should have a title, of course, a string, content should be string. Then we can copy from this datetime, these timestamps, like so. Do our formatting. Then let's also have published. Published to be a boolean value, boolean, and the at default should be false, like so. And then we can also write a unique table name. We call it blocks. Now, if you want to establish the relationship between the user table and the blocks table, so we can have a one-to-many. That is, a user can have many blocks, one-to-many or many-to-one. Many blocks belongs to a user, whichever way you want to look at it. So let's do our type relationship between a block and user. So we can call this guy user, then relation, that is fields, user ID, then references ID. Then we're gonna have user ID here of type int. Then the user, we can have blocks. Blocks equals to blog entity. This should be an array, not array. So let's explain this. We have a user having many blocks. We have an array of blocks here. So we can have block 1 object, block 2 object, block 3, and so on and so forth to block n objects. So one user can have many blocks. And here, one block can belong to only one user. So in this case, we have one to many. Coming back to the block, a block can belong to only one user here. So the next thing to do is to connect to our database. We have various ways to connect to our database. You can spin up a Docker container, and also if you have MySQL workbench like this installed locally, you can just create a new database. So I'll be using this approach because it's a lot simpler. Then we can create a DB, call this create database, called Prisma DB. Then we can say use Prisma DB, like so. So I'll run this guy. Then if I take my schema, so we have action create database Prisma, one row affected, use Prisma DB, 0 rows affected. So let's run our migration so that we can have the SQL equivalent of these models. So I'll open my terminal again, I'll clear, and I'll run. But before that, we need to change in our database URL. We have MySQL, we have the root password, then the default port is 3306 Prisma DB, and we are good. And don't forget to change your password. I'll not be showing you my password at the moment, so I'll blur it out. We have my password here and the username. Okay, so let's run npx prisma migrate dev. Then you can give it a name, give it init, call it init01. So we have your database is now in sync with your schema. Then it's loading that. Then created this migrations folder with the timestamp and the name of our migration in it. Then if I close this and this, then we go to our migrations folder, open this up. Then we have the SQL equivalent of what we just wrote. So we have the ID of integer not null, name, varchar, which is our string. We have 191, then password, and so on and so forth. Then the role, we have our enums here. The primary key is our ID because we said, where is our Prisma? Because we gave it this at ID, this annotation ID. Then for our create table, we have the blocks and so on. Then we added these foreign keys, these constraints. So user ID references the user ID on delete, restricts, blah blah blah. So if we go back to MySQL, then if we do select all from the users, because we gave it a name. If you remember, we said users. Then if I like this guy, then if I fire, you should have ID, name, email, password, profile pics, and so on. Then if I copy this guy and duplicate, we set blocks. So we have blocks here. Then if I run this guy, I should have the user ID here coming from this reference. This is our ID, like so. So let's create our Prisma connector. I'll come my source folder, create a new folder called utils. I can call it db. Then create a new file called connector.ts. Then we can bring in our Prisma. Then I'll import Prisma Client from at Prisma Client. Then you can create a new instance from this Prisma equals to new Prisma Client. Then we can invoke this guy, then just export this Prisma like so. So this is our connector. Then let's create a new folder called utils. Then you can have our c.ts. So I'll write class seed. Then we create a method called it's going to be an asynchronous method, async seed data. So I'll create a cycle count. So give it 10. So we just need 10 records. So we do a for loop. Do let I be equal to 0. As long as I is less than cycle count, then we can increment I++. Then we open this. Then we can do await Prisma. So we created the connector the other time. This Prisma. So do Prisma. Let's bring this guy in. Prisma dot users dot create. Then our data will be for email. For email. And for the email, we can do a string interpolation. Let's do user hyphen, then pass the I here at yopmail.com. Do this time 2 more times. Your password will be user hyphen pass. Remove this. Then what else do we have here? Let's check our Prisma. Name, email, password. Name, email, password. Okay. So name, we pass this guy here. Call it name. So it will be user 0 name or user 1 name, or let's start with 1, then make this guy 11. Like so. Format this. Then at the end of this code block, we can just log seeded. Then we can write const seed equals to new seed. Then seed data. So we have server is running. Then if I open another terminal, span this, I do ts node. Okay, this is hyphen source, we have utils, then seed.ts. So let's see what we have here. We have Prisma Client did not initialize yet. Please run Prisma generate. So let's check our JSON file. Did we import Prisma? No. Okay, let's import that. Let's install, npm install Prisma. Okay, just to be sure, let's run npm Prisma generate again. Okay, I think everything is fine now. Then we can do npx, can do ts node, source. What do we have here? Because we don't have users. Property user does not exist on the type Prisma client. So let's go back to our seeders. Yes, so it's going to be user, not users. It's going to be users because in our Prisma.schema we have the word user here, not the table name. So it's picking the entity name converted to lowercase. So let's look at how we can fix this. We have email. So the issue is we have email string password is not assignable to blah blah blah. Property updated art is missing. I saw it now. It's missing in type. So let's fix that because we don't want to pass it by default. We'll go back to our Prisma. Then for updated art, we just pass updated art here, like so, and add updated art like so. Then let's run this guy. So let's run the another migration Prisma nps Prisma migrate dev. The name is, let's do added default updated art. It's a very long name. Let's use this. So let's go back to, I think the error is gone now. Then we can run our seeder function. So what I'll do is I'll come here, I'll use ts node, the current folder, go to source, utils, then seed.ts, this particular file. Then if I run it, it's going to do an iteration starting from 1. Then you do a cycle count, then increment by 1. So let's fire this guy. So we have seeded. By the way, it should be outside. It should be outside like this. Let's put this guy outside so we can have it once, logged once. So if you go back to MySQL, then if I run user, you should have 10 records seeded into our database, like so. So the profile pic is missing because it's nullable. Then we have updated art. Why do we have the date here? Okay, we have the same date here. Okay, it's verified, is blocked, role, user, and so on and so forth. Or another approach is to make this field nullable if you don't want to see anything there. So you can put a question mark like so here. So we can make it nullable so that we will have null instead of having the date here. Anyways, we have these records already in our DB now. So the next thing to do now is to hash our password because we don't want to save plain password, plain text inside our DB. So I'll go back to my VS Code and I'll open inside the utils. I'll stop this for now. Clear the terminal and kill this. Then close all files, create another one called let's call it hash.ts. Then we can create a new class called password helper. It's going to be a static class, helper. Then we can have public static async hash password. Then we need to pass in our password like so. It's going to be of type string. Then returns a promise string. Then remove the second one. Then saying a function should return a value. That's correct. Then we need to return await bcrypt. Do we have bcrypt installed? Let's check. We have bcrypt here, then the types here. Okay, so let's import bcrypt.hash. Then we can pass our password, then the number of rounds, can make it 10 like so. Then let's import this guy, bcrypt imports bcrypt from bcrypt like so. Then format our code. Then we want to compare to copy this guy, call it compare password. So for compare password, we need two parameters. We need the password and the hash password. It's going to be a string to string, and this will return a boolean. So return bcrypt.compare password against the hash password like so. Then let's export this guy. We have export default. It's default password helper. Then in my setup function, come back here. Then let's import the password helper here first. Then let's use this password helper. So in case of password, we can wrap this. We can just do password helper dot hash password. Then you can remove this from here like so. Then we need to await this guy, and the error is gone. So before we run this, let's truncate our tables. I'll come here, I'll come to my MySQL bench, and I'll write truncate table. Because of the constraints, let's truncate the blocks first. This guy, and truncate users like so. So I'll truncate the two tables. Okay, block got truncated, but the tables, what did we get here? Copy response. Let's see. Reference in a Prisma, yada. Prisma, so TB. So what I'll do is I'll copy this, come here and paste. Let's see. So we need to set foreign keys check, blah blah blah. So I'll come here, I'll just paste it here. So let me set this guy. So we got a green. Truncate table, let's truncate users. So we got a green, then we can check it back like so. So I think we are good now. Then I'll remove this error. Then if I check my table again, we should have empty records. Makes sense. So let's go back to our code, then we can run that seed again. Then since we have that, let me just revert back to what I had before. 11 then seed. Then we can run this guy. You should have seeded. Go back to our table. Then we have our password hashed. So another thing that we can do is to create a script instead of running it from the terminal here. So I'll come back to my package.json and I'll call it seed. Then we'll do ts node. Then we'll go to source. Then utils seed.ts like so. So before we run the script, we saw how we can delete existing records by using this truncate. Another way is to come here. I'll come to my VS Code. I'll go back to my seed.ts. Then we can write a condition here. So I'll do user count equals to await prisma dot user, which is a model, dot count, like so. Then if user count is greater than 0, we can do await prisma dot user dot delete many. So we want to glean the DB. Then so I'll come here and do npm run seed like so. So we can have this seed there instead of writing the O command. Yeah, then I'll go back to my MySQL table and I'll click select and run this guy. Then we should have a password. And starting from 11. So the difference between the truncate approach and this method is that truncate will reset your record starting from 1 again, but this we just delete existing record if found, then insert new ones. But anyone that you want to use, you can use truncate. You can even use raw native queries inside your code base, but that is beyond the scope of this lesson. So I'll clear my terminal. A quick recap of what we have so far. We have our app running on TypeScript connected to a MySQL database via the ORM called Prisma. So in the coming lectures, we'll create a service layer, a repository layer, and a route layer so that we can communicate with our application via a testing client like Postman or Code Request or Insomnia. If you enjoyed this video and you want to see more of this, kindly subscribe to my channel and click on the like button, and I'll see you in the next class. Thank you.